I'm Harish. Today I'm going to explain about the topic in this presentation is biometric security, enhancing authentication with human traits. Let's move into the topic. First of all, let's see what are the contents in this presentation. Going to cover in this presentation is first, understanding biometric security. Second, biometric traits and authentication process. Third, application challenges and future trends. Okay, let's move into the topic. First, Section 1, Understanding Biometric Security. Let's move with the definition of biometric security. Biometric security refers to the use of unique physical or behavioral characteristics of individuals to verify their identity. These characteristics, known as biometric traits, include fingerprints, iris patterns, facial features, and more. Biometric authentication systems analyze these traits to grant or deny access to secure systems, devices, or physical locations. Next, importance of secure authentication. Secure authentication is essential for protecting sensitive information systems and physical spaces from unauthorized access. Traditional authentication methods like passwords or PINs can be compromised through theft, brute force attacks, or social engineering. Biometrics Biometric security offers a more reliable and difficult to forge authentication solution, enhancing overall security posture. Next, overview of biometric authentication. Biometric authentication involves capturing uh, biometric data from an individual such as fingerprint or facial scan and comparing it against stored biometric templates to verify identity. The process typically include uh, enrollment, where biometric data is initially recovered, and verification or identification, where the captured data is matched against stored templates to grant access. Next, biometric authentication provides a robust and convenient means of identity verification. Okay, emphasis on the role of biometric security, highlighting the pivotal role of biometric security in enhancing authentication processes and improving security posture. Call to action for enrollment phase. During the enrollment phase, an individual's biometric data is captured and stored in a database. This process involves the individual providing a sample of their biometric trait, such as fingerprints or facial scan, which is then processed to create a unique biometric template. The template serves as a reference for future authentication attempts. Then extraction. Feature extraction involves analyzing the captured biometric data to identify key distinguishing features or characteristics. For example, in fingerprint biometrics, features such as ridge endings, bifurcations, and ridge orientations are extracted from the fingerprint image. These features are used to create a mathematical representation of the biometric trait known as biometric template. Next, let's go with the template creation. Once the relevant features have been extracted from the biometric data, a biometric template is created. The template typically consists of a digital representation of extracted features encoded in a standardized format. This template serves as a unique identifier for the individual's biometric trait and is stored securely in a database for future authentication process. Next, there's another one process which I missed in this PPT is matching process. During the matching process, the biometric data captured during an authentication attempt is compared against a stored biometric template. This comparison is typically performed using mathematical algorithms that measure the similarity between the captured biometric data and the stored template. If the similarity meets predefined thresholds, the individual is authenticated and granted access. Section 2, Biometric traits and authentication process. Let's see about the type of biometric traits. There are fingerprint, iris in this slide. Let's see about that first. First of all, fingerprint. Fingerprint biometric involves capturing and analyzing the unique patterns formed by ridges, valleys, and minutae on an individual's fingertip. Fingerprint recognition is one of the oldest and most widely used biometric authentication method due to the distinctness and stability of fingerprints. Next, iris. Iris biometrics relies on the unique patterns found in the colored part of eye, known as the iris. Iris recognition systems use high resolution cameras to capture detailed iris images, which are then analyzed to create biometric templates for authentication. Iris patterns are highly distinctive and provide a reliable method of identification and verification. Let's see about the next types, other types. Retina. Retina biometric involves capturing and analyzing the unique patterns of blood vessels located on the back surface of the eye. Retinal scanning systems use infrared light to create detailed images of the retinal vasculature, which are then used for authentication purposes. Retina patterns are highly complex and difficult to replicate, making retinal scanning a secure biometric modality. Then, facial recognition. Facial recognition biometrics uses facial features such as the size and shape of the eyes, nose, and mouth to identify individuals. Facial recognition systems capture facial images using cameras and analyze facial landmarks and characteristics to create biometric templates. Facial recognition is widely used in various applications, including security, surveillance, and user authentication. Next, voice recognition. Voice biometrics relies on the unique characteristics of an individual's voice, including pitch, tone, cadence for authentication purposes. Voice recognition system capture and analyze vocal patterns and speech characteristics to create biometric templates. Voice recognition is often used in telephone-based authentication systems and voice-controlled devices. See about the advantages of biometric security. First, enhanced security. Biometric security offers enhanced protection against unauthorized access by providing a highly reliable means of authentication, unlike traditional methods such as passwords or pins, which can be forgotten, stolen, or shared. Biometric traits are inherently unique to each individual, making them difficult to forge or replicate. Next, convenience. Biometric authentication eliminates the need for individuals to remember and input passwords uh, or carry physical tokens such as keys or access cards. These convenience streamlines the authentication process, saving time and reducing the likelihood of authentication errors or delays. Next, accuracy. Biometric authentication systems typically exhibit low false acceptance rates and false rejection rates, leading to more accurate and reliable authentication outcomes. This accuracy ensures that authorized individuals are granted access while minimizing the risk of unauthorized access. Scalability. Next, scalability. Biometric security solution can be scaled to accommodate varying levels of security needs and organizational requirements, whether deployed in small-scale applications such as personal devices or large-scale systems such as enterprise access control. Biometric authentication can adapt to diverse environments and usage scenarios. Next, Section 3, Applications, Challenges, and Future Trends. And I personally read some case studies about the biometric security used by our Indian systems. First of all, let's see about that Aadhaar in India. Aadhaar is a biometric identification system implemented by the government of India. It assigns a unique 12-digit identification number to residents based on their biometric and demographic data, including fingerprints and iris scans. Aadhaar has been used for various purposes, including um, welfare programs, financial services, and identity verification, benefiting millions of individuals across India. And in Apple and all, in Apple Touch ID and Face ID, Apple Touch ID and Face ID are biometric authentication features integrated into iPhones and iPads. Touch ID uses fingerprints recognition technology to unlock devices and authorize transactions, while Face ID utilizes facial recognition to provide secure authentication. These features have become standard security measures on Apple devices, offering users convenient and secure access control. Next, airport biometric screening programs. Many airports around the world have implemented biometric screening programs to enhance security and streamline passenger processing. Biometric technologies such as facial recognition and iris scanning are used to verify passengers' identities at various checkpoints, including check-in, security, and boarding gates, improving operational efficiency and security features. These case studies demonstrate successful implementation of biometric security solutions in different contexts, highlighting the benefits of biometric authentication in enhancing security, convenience, and efficiency across various industries and applications. Next, let's see about the applications of biometric security. First, access control systems. Biometric security is widely used in access control systems to authenticate individuals' identities and grant or deny access to physical spaces, buildings, or sensitive areas. Biometric traits such as fingerprints, in iris patterns, or facial features can replace traditional access methods like keys or access cards, enhancing access methods like keys or access cards, enhancing security and convenience. Next, mobile devices. Biometric authentication is integrated into many mobile devices, including smartphones and tablets, to provide secure and convenient access control. Features such as fingerprint scanners, facial recognition systems, or iris scanners enable users to unlock their devices, authorize payments, and access sensitive data with biometric verification. Next, border control and immigration. Biometric security plays a crucial role in border control and immigration processes, where it is used to verify travelers' identities and enhance border security. Biometric data such as fingerprints, facial images, or iris scans can be captured and compared against databases to authenticate travelers and facilitate border crossings. Next, healthcare. In the healthcare industry, biometric security is employed for patient identification, medical records management, and access control to sensitive healthcare information. Biometric authentication ensures accurate patient identification, reduces medical errors, and enhances data security and privacy in healthcare settings. Biometric security has diverse applications across various industries, including access control systems, mobile devices, border control, and immigration and healthcare, enabling secure and convenient authentication solutions tailored to specific needs and usage scenarios. Next, challenges and considerations in biometric security. First, privacy concerns. In privacy concerns, biometric security raises privacy concerns related to the collection, storage, and usage of individuals' biometric data. Organizations must implement robust measures to safeguard biometric information, including encryption, access controls, and adherence to privacy regulations such as GDPR and CCPA. Next, vulnerabilities. Biometric systems are susceptible to vulnerabilities such as spoofing and presentation attacks, where Attackers attempt to deceive the system by presenting uh, fake biometric data. Mitigating these threats require the implementation of anti-spoofing techniques, uh, liveness detection mechanisms, and continuous monitoring of system integrity. Next, implementation cost and complexity. I missed in this PPT, but I will also explain about that. Deploying biometric security solutions can involve significant upfront costs for hardware, software, and infrastructure, as well as ongoing maintenance expenses. Additionally, integrating biometric systems with existing IT infrastructure and business processes may require expertise and resource adding to the complexity of implementation. Next, regulatory compliance. Organization must ensure compliance with relevant regulations and standards governing the use of biometric data such as GDPR, CCPA, and industry-specific guidelines. Compliance requirements may include obtaining explicit consent for biometric data collection, implementing data protection measures, and providing individuals with rights over their biometric information. Next, addressing these challenges and consideration is essential for the successful implementation and operation of biometric security solutions, enabling organizations to maximize the benefits of biometric authentication while mitigating associated risks. And next, uh, future trends. First one, continuous authentication. Continuous authentication refers to the ongoing verification of users' identities throughout their interactions with a system or application, unlike traditional authentication methods that occur only at login. Continuous authentication continuously monitors user behavior and biometric traits to ensure ongoing security. This approach enhances security by detecting anomalies or unauthorized access in real time. Multimodal biometrics. Multimodal biometrics involve the combination of multiple biometric traits for authentication purposes. By leveraging multiple biometric modalities such as fingerprints, facial features, and iris patterns, multimodal biometric systems enhance accuracy, reliability, and security. This approach mitigates the limitations of single model biometrics and provides a more robust authentication solutions. Biometric wearables and implants. Biometric wearables and implants represent a growing trend in biometric security where biometric sensors are integrated into wearable devices or implanted directly into the body. These devices continuously monitor biometric data such as heart rate, body temperature, or vein patterns, providing secure and seamless authentication without the need for external hardware or manual input. Next, integration with AI and machine learning. The integration of biometric security with artificial intelligence and machine learning technologies enables advanced authentication methods and threat detection capabilities. AI-powered biometric systems can adapt to users' behavior patterns, identify anomalies, and improve accuracy over time by learning from data. This integration enhances the effectiveness and resilience of biometric authentication in dynamic environments. These future trends in biometric security reflect ongoing advancement in technology and innovation, offering opportunities to further enhance security, usability, and efficiency in authentication systems. Next, the best biometric implementation. First, secure storage and encryption of biometric data. Biometric data and biometric data should be securely stored using encryption and robust access controls to prevent unauthorized access or data breaches. Encryption ensures that biometric templates are protected both in transit and at rest, minimizing the risk of data compromise. Next, regular updates and patches. Regular updates and patches should be applied to biometric system to address security vulnerabilities and ensures the latest security features are implemented. This helps mitigate the risk of exploitation by attackers and keeps the system resilient against emerging threats. User educations on biometric security and privacy. Users should be educated about the importance of biometric security and privacy, including how their biometric data is collected, stored, and used. Clear communication and training programs can help users understand their rights and responsibilities regarding biometric authentication. Next, collaboration with regulatory bodies and standard organizations. Organizations should collaborate with regulatory bodies and standard organizations to ensure compliance with relevant regulations and industry standards governing the use of biometric data. This collaboration helps organizations stay informed about legal requirements and best practices for biometric implementation. Implementing these best practices ensures that biometric security solutions are deployed and operated in a manner that prioritizes security, privacy, and regulatory compliance, thereby maximizing the effectiveness and trustworthiness of biometric authentication systems. Yeah, thank you. That's it.